Ladies and gentlemen, dear colleagues, my name is Krsto Lazic, and I would like to use this opportunity to greet you all on my personal behalf. Today I will be talking about implementation of adaptive streaming over HTTP on Android-based DTV platform. First, I will give you a short introduction in the various standards that have been implemented. Then I will present the concept of the solution for both of these implementations. And finally, you will have the chance to hear something about the implementation details and future plans. Although adaptive streaming is much of a self-explanatory term, I decided to give you a short introduction into this technology because it is so important for this work. Adaptive bitrate streaming is a technique used in streaming multimedia content over computer networks. It works by detecting the user's bandwidth and the CPU capacity, and all of this is done in real time. And it is adjusting the quality of the multimedia content accordingly. The content is encoded into various bit rates, and all of these multiple bitrate streams are then segmented into multiple segments. So the streaming client has the freedom to choose at what bitrate will each of these segments be downloaded, and thus he can adapt to his current bandwidth. The result of this technology is very little buffering, very quick start time of the playback, and it gives a good experience in both high-end and low-end connections. Adaptive streaming is now being developed and utilized by many leading companies. Some of them are Microsoft, Adobe Systems, Apple, and many more. All of these standards are very similar to each other, but they are completely incompatible, and this represents a serious problem in this area. For this work, we chose two basic standards. The first standard is HTTP live streaming, and the reason why we chose this standard is that it is very popular at the moment. The second standard is MPEG-, where dash stands for Dynamic Adaptive Streaming over HTTP. And the reason why we chose this standard is that this standard should represent the future of adaptive streaming. It should replace all the other standards that are currently on the market and thus overcome their mutual incompatibility. HTTP live streaming is an HTTP-based streaming media communication protocol to transmit streams of multimedia data. It works by breaking the overall stream into a sequence of small HTTP-based file downloads. The manifest file, which is used to obtain all the needed information about the stream, is called an extended M3U playlist, and it is called an M3U8 playlist. The content may be selected from a number of different alternate streams containing the same material encoded at a variety of bit rates. Now, MPEG- is a little bit more complex than that because it supports much more features than HTTP live streaming. It defines a way to advertise a range of different streams to a player and media file formats suitable for adaptive streaming. The content exists on the server in two parts. The first part is an MPD document. It's short for multimedia presentation document, and that's the manifest file from where the client can obtain all the needed information for streaming the content. And the other part is the segments. The segments represent the actual multimedia content. The MP Dash is very rich in features, and some of those features include switching and selectable streams, ad insertion, so advertisements can be inserted between segments or between representations, fragmented manifest segments with variable duration, and the specification also defines 5 specific profiles, and each of these profiles are addressing different class of applications. Each profile defines a set of constraints, limiting the MPD document and segments to a subset of features of the entire specifications. Therefore, the Dash client needs only to implement those features that are required by the profile that it implements. In this figure, we can see a simple client implementation. The Dash client first obtains the MPD document. The document can be obtained via HTTP or email or any other communication. So when the MPD document is obtained, it is passed, and all the information are collected from it. The most important information are URLs of the segment. When the client knows where the content is located, it can start downloading segments one by one, and this is done via HTTP. From 3.0 version, Android supports most of the functionality of HTTP live streaming. The problem is that it has a lack of adaptation logic. When we are talking about HTTP live client, all the heuristics resides on the client side, which is a direct consequence of using HTTP technology. In this implementation of HTTP live streaming in Android, the software decoding is done. The decoding is done in software, so that is really unacceptable on embedded platforms. So we suggested 2 solutions for that. The first solution is that we design a custom player which will be using the API of the hardware decoding module, and the second solution is to modify the already existing vendor-specific player. Now I will present you a short example of HTTP live streaming. First, the playlist, the M3UI, the M3U8 document is downloaded, and after it is passed, the segment fetching can start. The playlist is reloaded periodically, and the period of time of the reload time is based on the length of the varied segments. Then the client measures the bandwidth of the channel, and depending on the bandwidth state, it adapts to it. As for MPEG Dash, to play the content, Dash client first obtains the MPG document. The MPG document is an XML document, which has a highly hierarchical structure. The MPD document consists of multiple periods, and each of these periods have multiple adaptation sets. Each of these adaptation sets consists of different representations which represent different bitrate streams of the same content. The client first selects adaptation sets within each of these adaptation sets, it selects one representation and starts downloading. The download is based on the segment list, which is created according to the MPD document. All the modules are implemented in the native layer, and they are bound to the TV application through JNI level. The most important thing about the modularity of this solution is that the modules are reusable and can be used in implementing other profiles of MPEG-. For this implementation, we used a simple adaptation algorithm which served only the purpose of verification of the implementation. Both of these implementations have some common modules, and those common modules are player, adaptation logic, and HTTP manager. Interfaces of these modules had to be carefully designed to enable the use of segments in both implementations. So the direct consequence of this is when we implement more advanced adaptation logic in one standard, the consequences is that it can be used in the other standard with no change. The other advantage of modularity of this solution is that the implementation can be upgraded with additional features incrementally, so there is no change needed for the existing code. The trickiest part in this implementation was the player module. Because it is the only platform-specific module. The implementation of both standards needed to have a simple interface towards this module to enable portability of the solution. The most critical part was the representation switching. So when the client decides to adapt to another bitrate stream, in order to avoid picture freeze, we needed to change the vendor-specific player module. So those changes included doing the probing of the stream in parallel with decoding the previous segment. I presented the implementation of two standards, MPEG- and HTTP live streaming on Android-based DTV platform. The most important thing is that the solution is designed to be modular. Future work for this project include designing an advanced adaptation logic algorithm and creating an environment for repeatable scenarios so we can test these advanced adaptation algorithms. Thank you.
Thank you very much. Any questions? Okay, no questions so far, so let me ask first questions on the adaptation logic. I know you only use a very simple one, and on the server, what is the time period of a typical segment and how fast can you switch to another band?
Typical segments are between 5 and 10 seconds long. I think the shortest segment can be 1 second long, so that's pretty much enough time to do the adaptation. We can do the bandwidth measurement at some periods of time and use those information for adaptation. So the current adaptation algorithm only concerns the last bandwidth measurement, and according to that last bandwidth measurement, it decides at what bitrate it will download the next segment.
On the next segment, which could be 10 seconds.
Yes, 10 seconds.
And I mean, you measure the bandwidth from the throughput, but how to switch to a higher bandwidth? I mean, you measure how many data comes in per second. Isn't it a bit tricky then to go up to higher bandwidths to measure it?
We measure the download speed of the previous segment.
Okay.
So according to that, we can. The information in the MPT document is that for every stream is the measurement in bits per second. So if we measure the speed that we downloaded the last segment, we can easily switch to a higher bit rate if the speed was higher than the previous segment bit rate.
Okay. So some more questions. Some questions around the audience. So if this is not the case, then thanks to speaker again.